Next, we're going to discuss the sum and difference formulas for sine, and they're derived in the same manner as the formulas for cosine of sum and difference. And in this video, we're just going to see how we're going to use it. I may record another video with the derivation process. We'll see. For now, let's see how we can apply them. It says, example 3 says, use the sum and difference identities to evaluate the difference of the angles and show that part A equals part B. Okay, so we're gonna first part A, sine of 45 degrees minus 30 degrees. We're gonna rewrite it using our formulas. So that's sine of alpha, which is 45 degrees, times the cosine of beta, which is 30, minus cosine of alpha, which is 45, times the sine of beta, which is 30. So these formulas are symmetric with the cosine formulas, but there are differences. So remember, in the sum of cosine, we had plus here, minus here. So with the sine, we have plus and plus, and these ones are like with the cosine, we had sine alpha times sine beta, and then cosine alpha times cosine beta. Here, we're alternating alpha and beta in the products. So keep that in mind. That's how these formulas are different. So let's go ahead and evaluate this expression. So it's just a matter of filling in the values, the known values of the angle that we studied since the beginning of the course, and basically combining, multiplying those fractions and combining those fractions. I don't want to waste your time here. I know that you can do that by yourself. Just wanted to make sure that you remember that square root of 6 and square root of 2 cannot be combined because they're not like radicals, so they're just stayed like that. Okay, let's now take a look at expression B. We have sine of 135 degrees minus 120 degrees. So again, applying our formula, we're going to have sine alpha times cosine beta minus cosine alpha sine beta. All right. So again, we just have to fill in the values from the known values from the unit circle. These are known angles. And here we go. Again, multiplying and simplifying. This is what we get, a root of 6 minus root of 2 divided by 4. And as you can see, those values are absolutely identical. All right, so what is 45 minus 30? That's 15 degrees. What is 135 minus 120? It's also 15 degrees. So it makes sense that in the end we got the same result. And also notice that we can express 15 degrees in different ways as well. Now let's take a look at example 4, and this example is slightly different and slightly more interesting. It says, find the exact value of sine of the inverse cosine of 1/2 plus inverse sine of 3/5. Okay, now remember that the result of the inverse cosine, the output of the inverse cosine is the angle, and we're going to call it angle alpha. And the result of the inverse, or the output of the inverse sine function, is also an angle, and we're going to call it angle beta. So essentially, what we're looking at right now, this is a sine of alpha plus beta. So we're going to treat it as such, and we're going to apply our sine of a sum angle to this expression. So what we're going to get, we're going to get sine of the first angle, which is inverse cosine of 1/2, times the cosine of the second angle, which is the inverse sine of 3/5, plus the cosine of the first angle, which is the inverse cosine of 1/2, multiplied by the sine of the second angle, which is the inverse sine of 3/5. All right. So we know that the angle whose cosine is 1/2 is actually angle pi over 3, right? So we can fill it in. We can just change it to pi over 3. Now, what about this sine, inverse sine of 3/5? Well, 3/5 is not one of our known values, right? So we would have to use our Pythagorean triangle identities, okay? The triangle identities, the right triangle identities. So if we're gonna draw a right triangle with our angle theta, and we know, so this is our theta, we know that the sine of that angle is 3/5. So that means that the opposite side of it is 3, the hypotenuse is 5. So our leg, the adjacent side to angle theta, is 5 squared, which is 25, minus 3 squared, 9. So this is going to be a square root of 16, which is 4. So we have the opposite side is 3, the adjacent side is 4, the hypotenuse is 5. So what is the cosine of that angle? So this is our angle beta or theta. Yeah, this is beta, actually. Okay, so what's the cosine of this angle beta? The cosine is going to be 4/5. All right, and here we have a sine of that angle beta. And the sine, well, we know that it's 3/5. So we're gonna plug in 3/5. That's it. So we have multiplication going on here, multiplication, and the plus here. So just the sine of pi over 3, of course, is a square root of 3/2 times 4/5 plus, and then the cosine of pi over 3 is 1/2 multiplied by 3/5. What do we have? Well, we have 4 roots of 3 over 10 plus 3 over 10. So in the end, our answer is going to be 3 plus 4 square roots of 3 over 10. And that's our answer to this problem.